So I'll jump now into a little bit of what's going on the wire, the actual message sequencing. So as I said previously, the most common method for uploading files is for the target to be in automatic mode. So most commonly what's used is simply the config LDR file has a sequence of files to upload and to download. The operator inserts or selects that media at the data loader, and then the data loader just executes the sequence of events specified in the config LDR. So what the automatic file upload would look like actually on the ARINC 429 bus is shown here. So the first thing that happens when the user selects and starts an upload is the data loader will send a request to send message. So this is a busword, a 32-bit ARINC 429 label busword. The data loader will pull that, so he will send the request to send repeatedly at a regular rate until he receives a response back from the target side. So in this case, if the target accepted that operation, he would reply with a clear to send. And after that, the data loader would send a data follows word followed by a sequence of data words, and then those sequence of data words which contain the contents of the file would be would have at the end what's called a final word that includes a checksum in it. And that checksum is the checksum calculated over the sequence of data words between the data follows and that checksum word. The target uses the sequence of data words in that checksum to check that the data is valid, that we haven't had any data integrity issues on the wire. And if it validates that, it would send an acknowledge back to the data loader, which would trigger the data loader to send the next data follows and next sequence of data words and so on. In the request to send and clear to send message exchange, the data loader indicates a record count that it wishes to send. So the record count is basically that sequence of data follows, data words to final word. It's how many times he wants to repeat that. And the target acknowledges and accepts that record count by indicating the record count that it's ready to receive in the clear to send. So the data loader repeats this data follows the record count number of times. So the number of times indicated in the record count in the clear to send message. After that, after record count is completed, the data loader will then send another request to send and repeat the whole process again. So a little vocabulary, a record, if you're looking through the ARINC 615 spec, a record is basically the unit of information that's contained in the sequence of data words between the data follows and the checksum, where a block is a sequence of records that are sent between request to sends during the load process. Sorry, I went backwards there. Okay, a little bit more detail about the actual bus words that are on the wire in the sequence that we showed previously. So here you can see the contents of a request to send. So it's pretty easy. It's sent to the label that's defined in the config LDR for that target on that bus, and it includes a count of the number of records that the loader would like to send. Then the clear to send, the acknowledgement that comes back, very simple. It also includes the count of records that it's ready and willing to accept. So this could possibly be a lower number than the number of records that are requested in the request to send. Then we have the data follows, and the data follows indicates which record within the record count and also the number of records. So it would indicate this is record 1 of 5 or 2 of 5, etc. Then you have the data words, which are simply not shown here, but they're simply just the label, and then the payload is the data that's taken, the chunk of data that's taken from the file that's being transferred. And then there's the acknowledge, which is sent back after the checksum final word is sent, and it also indicates which record is being acknowledged. So as I said, we can also do download operations, so we can pull data files down from the target to the loader. So we'll go through a message sequence of what goes on when the download operations occurs. So this time, when we're going to do a download, instead of polling or sending repeatedly a request to send message, the data loader will send repeatedly and at a regular rate a poll message on the bus. And when the target is ready to send the file to the data loader, he will respond with a request to send to the poll. And then basically we have the same thing as the upload, except the roles are reversed. The data loader in this case then replies to the request to send with the clear to send, with the record count acknowledged in there, and then we have our sequence of records between data follows and checksum words and acknowledges. And then we also have our sequence of blocks, so you can have multiple request to sends and acts in that case. So same as the upload, only difference is the data loader starts with a pull message to trigger the target to send the request to send. Again, as I said, there's also a less used, but it is an option that's available in the specification, where the target can put the data loader into what we call a control mode, and the target can essentially be the master and controller of operations. The way this would look like on the bus, if the target wanted to go into control mode, is say the data loader has encountered in the config LDR a transmit or an upload definition, so a file that it needs to upload. It will start polling the request to send to the target, and instead of responding with a clear to send message, the target will respond with a control mode command, and then telling the data loader that it wants to go into control mode. The data loader can acknowledge this and accept, go into control mode. Then the target can send read block commands. There's also write block commands and several other commands that are defined in the spec, essentially to tell the data loader what it wants to do next. And after that, you basically have your same sequence of operations, either a pull from the target or a request to send, depending on which way the file is being transferred. Pardon me. So that's our overview of the protocol. A little bit about what we provide, what AIT provides in support of ARINC 615. We have a full line of ARINC 429 interface modules, so PXI Express, PCI Express, PCI modules, VXI, VME. We also have a USB ARINC 429 interface with up to 16 channels and with discretes on that also. And so we can use that with our data loader software application to provide a portable data load solution. All of our hardware channels are fully programmable as transmitters and receivers, so we can support with the hardware and the data loader software, a wide variety of different configuration options. And our data load software, we provide a GUI, a user interface, which shortly here John Cole is going to demonstrate some of the data load operations within that user interface to you. And we also provide a command line interface, so you can script and batch operations from a command line. The 615 operations. So with that, if you give me a moment here, I'm going to turn over the presentation to John Cole and let him show you a short demo of our software.
Okay, hopefully you can see my screen here. Basically, I'm going to take you right into the simulation portion of this demo, just because it's kind of the more interesting part. But I will take you back and show you how to configure the hardware in just a second here. To start off with, when you boot Flight Simulator into the ARINC 615 data load mode, the first option that you need to set is basically where the config loader file is. So in this case, I have a test one set up. We pointed at the file, and as Troy mentioned in the spec, there's a lot of discussion of floppy disks. We do not use floppy disks. You don't have to worry about that if you use our software. Basically, if you have a config loader file nested down in a disk directory with other disks, you point it at one of those files, and it will find all the rest of the files and handle processing files between config loaders and files that span disks, things like that, and that's all handled for you. So you set the config loader file. There's some options in here. This use exconfig and this version description info tab that you see are disabled. These are some additional advanced options that you can do with data loading that we do support. They're not real commonly used though. This decode message data is an option that basically allows you to decode the ARINC 615 messages as you're going back and forth between data loader and the target. So it's really useful if you're trying to debug issues that you're having. And then this status info level is basically you set an option here, and it'll basically discuss how much information you get from the data loader as far as what the data loader is doing internally. It gives you everything. I have it set to verbose mode here from simulation that I ran with our simulated target. And you can see it tells you kind of everything that's happening as the sequence is going along here. There's also a file transfer count that shows you it's clicked up every time a file is uploaded or downloaded. And then you've got this file progress, which shows the transfer progress of the current file that it's working on. Then there's an overall transfer progress. The time elapsed, and then we have these LED indicators showing you kind of what's going on at any given time. As far as the message decoding goes, if you look here, you can see that the data blocks, just like Troy talked about, is all decoded for you, so you can dig right down into what's happening with the actual protocol. This status is actually tied to this. So if you run into an error or something, you can scroll down to the bottom and say, okay, I want to see what happened here. This is the last message that went out that was correct. You can see, come here and see, oh, well, it looks like the target quit responding or something like that. And then these are actually linked together with the raw data, which if you really want to dig down into the guts of the transfer, you can flip back and forth, and this will allow you these are linked together, so you can flip back and forth and see look at the actual data if you wanted to go down into the guts of it. And that's pretty much it. I have a simulated target run. I'll just go ahead just to kind of show it in action, what happens while it's running. But so this, as it comes along here, while it's running, you can run along here. I'm going to pick my target and get behind here, but that's kind of just the idea of what happens here. I'll kick you over to the settings side here, as I told you. Basically, if you come into the settings for the 429 data loader, you can configure multiple data loaders at a time. And so theoretically, you could run multiple loads. If you have a board that supports the channel count that you need for your loads, you can set up separate data loaders and have them running simultaneously. So you configure data loader. You have your TX channel assignments, which, as Troy showed in the config loader file, you have data loader channels, 1 through 4 for TX. So you can tie those to an actual hardware channel. And then same thing with the RX. You have RX channels that you can do up to A615 channels that are supported by a config loader file. And you tie those to an actual hardware channel on the board. And then there's also discrete options. I don't think Troy actually discussed that. That's just an additional option that you have within a config loader. It's not real commonly used, but our hardware has discretes available, so you can use that if required. There are also some advanced options here that show basically that you can kind of set the data loader to run outside of the spec for different delays and retry counts, things like that, if you wanted to kind of play around with different settings. If you're having problems with the target, it kind of helps you figure out how to do that. But I guess that's pretty much it. It's pretty straightforward. There's not a whole lot here. I guess I should also mention that import, export, you can save this configuration off and just import it back again. So if you're doing the same type of load or something, you can just reload it again. And then I also forgot to mention here, with your message decoding, you can actually export this information. So like a tech or something in the field probably doesn't know about the protocol, how that works. So theoretically, they can come in here and they can save all of the data from the capture to have somebody else go in who does know about the protocol to go in and kind of debug what's going on. So that's just kind of a nice option. You can just turn off the message decoding if you don't care about it, which a lot of people won't. But it's there if you need it. So that's pretty much it, though.
Okay. Thanks, John. That basically concludes our webinar today. I'm going to put back up the home screen here so everybody can see my email address and John Cole's email address. If you guys have any questions, please feel free to send us an email directly. Thanks again for joining us. And again, any questions, let us know. Bye-bye.